Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 12, 2026, just 6 days ago. It introduces a framework called UniT that enables unified multimodal models to iteratively reason and self-correct, achieving a massive 53% gain on out-of-distribution visual reasoning. The paper is titled UniT, Unified Multimodal Chain of Thought Test Timescaling. And as we'll see later, the results suggest that teaching models to think sequentially is far more efficient than just asking them to guess multiple times. Figure 1 illustrates this framework in action. The top panels show compositional editing, where the model sequentially zooms in on a bird, changes the background, and adjusts brightness based on a complex prompt. The middle row demonstrates multi-turn editing, tracking context to correctly interpret pronouns like it when swapping food items. Finally, the bottom charts reveal the payoff. Across 4 benchmarks, the blue lines for sequential chain of thought scaling consistently outperform the green lines for parallel sampling, proving that reasoning step-by-step yields far better results than just generating more independent guesses. Alright, so figure 1 showed us the end result, but how do we actually get the training data for this? Figure 2 breaks down the agentic framework used to synthesize these reasoning chains. It starts with a prompt at the top, asking for a bookshelf with no books, only picture frames. An initial generation model creates an image, but as the first panel shows, it mistakenly includes books. Here, a vision language model steps in as a verifier. It spots the error, explicitly plans to remove all books, and signals an editing model to fix it. The process iterates in the middle panel, where the model realizes it removed the books but forgot the frames, so it corrects itself again. Finally, the bottom panel confirms the prompt is satisfied, producing a complete reasoning trajectory that the unified model can later learn from. So, having established the training pipeline, Table 1 now quantifies the impact on compositional generation using the 1IG bench. The table compares UniT against strong baselines like Janus Pro and the standard Bagel model across varying prompt lengths. You can see that adding text-only chain of thought to Bagel, shown in the 4th row, bumps the overall alignment score to about 0.79. However, UniT, in the bottom row, jumps significantly to 0.84. Crucially, look at the long column. UniT maintains high performance even with complex instructions over 60 words, where standard models typically falter. Well, Figure 5 reveals a fascinating property called Beyond Training Generalization. The blue shaded area represents the training data, where reasoning chains are relatively short, peaking around 3 rounds. In contrast, the sign distribution shows that at test time, the model naturally extends its reasoning to longer chains, averaging nearly 5 rounds. Crucially, the purple line demonstrates that this extra effort pays off, as the mean benchmark score steadily climbs with each additional generation round. Alright, while Figure 5 confirmed that reasoning helps, Table 5 dissects which specific behaviors actually matter. It removes verification, sub-goal decomposition, and content memory to see what breaks. The most dramatic result is in the 3rd column, image edit score. If you look at the bottom row, removing content memory crashes the score from 4.26 down to 2.45. This proves that tracking visual history is essential for multi-turn editing. In contrast, the 3rd row shows that removing sub-goal decomposition primarily hurts the 1IG alignment score, confirming that breaking down instructions is vital for compositional tasks. To wrap up, UniT demonstrates that test time scaling is just as powerful for multimodal tasks as it is for text. By enabling models to verify and self-correct, we move closer to unified systems that don't just generate images, but actually understand and refine them. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.